Hello students, welcome to the new video. This is the lecture number 7 in JNTUH Basic Electrical Engineering previous year bit paper questions and solutions. In this lecture, we'll discuss the fill in the blanks questions of alternating quantities fundamental concepts. So let us start with the first question. It's about the time period and frequency. The time period of a sinusoidal wave with 200 Hz frequency will be how much? So frequency is given how much? 200 Hz. What it is asked? Time period is asked. So time period T is equal to what is the relation? So T is equal to 1 by frequency. So 1 by F. 1 by F nothing but 1 by 200. So 1 by 200 is equal to 0.005, and time period units are nothing but what? Seconds. So T is equal to 0.005 seconds. Let us see the second question. What is the unit of susceptance? Unit of susceptance is what? Susceptance is nothing but it is the reciprocal of reactance. So reactance units are nothing but what? Ohms. Reciprocal of ohms are nothing but what? Siemens. So unit of susceptance is Siemens. Third question. The standard supply frequency in India is how much? So in India, power supply standard AC power supply frequency is 50 Hz. In US, it is 60 Hz. And let us start with the fourth question. An AC generator having 6 poles. So P is equal to number of poles. P is equal to how many? 6 poles. Is required to generate voltage at 120 cycles per second. So 120 cycles per second nothing but what? It is frequency. Frequency is equal to 120 Hz or cycles per second. And then what is the speed of the generator? So speed of the generator N we need to find. We have the formula N is equal to 120 F by P. So that is equal to 120 into F nothing but what? 120, and P number of poles P nothing but what? 6. So 6 2s are, so 120 into 20, it is 2400, and speed units are nothing but what? RPM. 2400 RPM. Very important relation. N is equal to 120 F by P. Next, fifth question. A 4-pole DC generator P is equal to 4 is running at 1500 RPM. So speed N is equal to what is the speed? 1500 RPM. And the frequency of the current induced in the armature is. So frequency F we need to find out. So what is the relation we know? F is equal to Pn by 120. F frequency F is equal to Pn by 120. P nothing but what? 4. N is 1500 RPM and divided by 120. So here 0 0 cancel. 4 3s are, and 3 5s are, and 0. So frequency F, frequency of the current in the armature F is equal to 50 Hz or 50 cycles per second. Next question. AC power supply is completely described with a dash. So with what quantities we will describe the AC power supply? So AC power supply we describe with a magnitude as well as frequency. Magnitude, frequency we will describe. Next question. Question number 7. A sinusoidal voltage varies from 0 to maximum of 250 volts. So Vm value what it is given? Vm is equal to 250 volts. The voltage at the instant of 60 degrees is how much? So at the we need to find omega t is equal to 60 degrees. What is the voltage we need to find? So general sinusoidal voltage equation is what? V is equal to Vm sin omega t. So that is equal to Vm. So what is the maximum value of the voltage? 250 volts. 250 into sine 60. So if you calculate this value, you will get the answer approximately 216.5 volts. Next question. Question number 8. An alternating current is represented by I is equal to 70.7 sine 520t plus pi by 6. What is the frequency and what is the RMS value of the current we need to find. So what exactly current equation is given? I is equal to, we know general current formula, sinusoidal current formula, I is equal to Im sine omega t. But let us say this is equation 1. And what is given in the question? I is equal to 70.7 sine 520t plus pi by 6. Let us say this is equation 2. So by comparing equation number 1 and 2, so you will come to know Im value is how much? 70.7. So Im is equal to 70.7. Peak value of the current is 70.7 amps. And if you compare this 520t and omega t, then omega is equal to what? 520. And what exactly we need to find? Frequency we need to find, RMS value of the current we need to find. So from this value we know omega is equal to 2 pi f. So 2 pi f is equal to 520. So from this equation you will get frequency is equal to 520 by 2 into pi, nothing but what? 3.14. So frequency f you will get as approximately 82.7 hertz. This is a frequency. Important formula, omega is equal to 2 pi f. And then other thing what we have to calculate, RMS value of the current. RMS value of the current, IRMS is equal to, we represent with capital letters, that is peak value by root 2, Im by root 2. So this is the formula for RMS current in case of the sinusoidal wave, Im by root 2. So what is the peak value of the current is given? 70.7. So that is equal to 70.7 divided by root 2. And you will get approximately 50 amps. So frequency is how much? 82.7. And RMS value of the current is how much? 50 amps. Next, question number 9. An AC current is given as 10 plus 10 sine 314t. What is its average value? We need to calculate the average value. Average value of 10 plus 10 sine 314t. See, this 10 is a constant, so we will get 10 only. But for sinusoidal quantity, the average value is going to be 0, 10 plus 0. So the average value is nothing but what? 10. Let us say if you want to calculate the RMS value, so in case of RMS value, we have to use this formula. So this constant part square plus, so this Vm by root 2, let us say this is Vm sin omega t, Vm by root 2 becomes what? RMS value, 10 by root 2 whole square. In this manner, we will calculate the RMS value. Next question, 10th question. So it is asked the ratio of RMS value to the average value. It is very popular formula. Form factor is known as RMS value divided by average value. Very important formula. And peak factor is nothing but what? Peak value by RMS value. Next question. Question number 11. A constant current of 2.8 ampere exists in a resistor. Then the RMS value of the current in a resistor. So here it is mentioned that this 2.8 amperes is a constant current. So constant current is nothing but what? RMS value is also becomes RMS value nothing but what? Constant current. So RMS value of the current is 2.8 amperes only. Next question. Form factor is the ratio of dash to dash. Form factor is nothing but it is a ratio of RMS value to the average value. RMS value to the average value. That is nothing but what? Form factor. Form factor of a sinusoidal wave is how much? So for a sinusoidal wave, form factor is 1.11. So don't confuse, for all the waves, form factor is not 1.11. Only in case of a sinusoidal wave, if I calculate the ratio between RMS value to the average value, we'll get the form factor as 1.11. Next, what is the form factor of the DC supply voltage? For DC power supply voltage, the form factor is going to be 1. For in case of DC power supply voltage, RMS value and average value both become same, then the ratio becomes what? Unity, 1. Next question, question number 15. A sine wave has a frequency of 50 Hz, and what is its angular frequency? So F is given as how much here? 50 Hz, and angular frequency nothing but what? Omega we need to calculate. Omega is equal to, what is the formula? 2 pi F. So that is equal to 2 pi into 50. That is equal to how much? 100 pi. So angular frequency is how much? 100 pi. Next question. The form factor of a sinusoidal or cosine wave is how much? So for sinusoidal or cosine wave, the form factor is will be 1.11. Next question. Question number 17. The RMS value of the sinusoidal voltage is how much? So let us say if Vm is peak value of the sinusoidal voltage, then RMS value is going to be what? Vm by root 2, or we can say 0.707 Vm. This is the RMS value of the sinusoidal voltage. Next question. If the maximum value of a sinusoidal wave is 100 volts, maximum value of sinusoidal voltage, peak value or maximum value is how much? 100 volts. Then what is the RMS value of the voltage? So RMS value of the voltage formula, Vrms is equal to Vm divided by root 2. This formula for RMS only in case of which wave? In case of sinusoidal wave, that is 100 by root 2. So this becomes approximately 70.7 volts. Next question number 19. Form factor of alternating quantity is given by RMS value of alternating quantity divided by average value of alternating quantity, that is form factor. Next, question number 20. Form factor for triangular waveform is, so you need to calculate RMS value for the triangular waveform, you need to calculate average value for the triangular waveform. So then we will get the answer as Vm by root 3. So I am assuming Vm is a peak value of the triangular wave, then form factor will get as Vm divided by root 3. Next, it's about the very important J operator. The symbol J represents dash rotation of the phasor, dash decrease. So anti-clockwise direction, anti-clock rotation, or counter-clockwise rotation, counter-clockwise rotation by how many degrees? 90 degrees. Let us say this is one vector A. If you multiply A vector with a J operator, then it has to rotate in anti-clockwise direction by how many degrees? 90 degrees. Then it becomes what? This becomes what? AJ. Again, if you multiply this AJ with J operator, again it is going to rotate in the anti-clockwise by 90 degrees. But there is no change in the magnitude of the vector. Only it rotates 90 degrees in the counterclockwise direction. Right? This is a J operator. Very useful operator. Next question. Question number 22. The length of a phasor in a phasor diagram normally represents the dash value of the alternating quantity. That means whether it represents peak value or RMS value or average value. So the length of the phasor in the phasor diagram is going to represent RMS value of the alternating quantity. RMS value of alternating quantity will be represented by the phasor diagram. Next, question number 23. It is about the types of powers. The phasor combination of true power and useless power is, the phasor combination of active power and reactive power. True power is active power, useless power is reactive power. So both the powers resultant phasor power is what? It is operant power. So what is the answer? Operant power. Next, question number 24. Phasor diagram is used to represent the relation between two or more sine waves of same frequency. If the waves are having the same frequency, then only we can represent them in the phasor diagram. So waves should have the same frequency. Next, question number 25. The magnitude and phase current of phase of current vector depends upon the values of dash. So it depends upon the resistance, it depends upon the inductance, it depends upon the capacitance value, it depends upon the frequency also. Question number 26. The opposition to the flow of alternating current is called impedance. So impedance nothing but impedance represents, it is the opposition to the flow of current. So next, about the power factor. Power factor of an AC circuit is defined as dash. So let us say if you want to define power factor in terms of RLCZ, power factor is equal to R by Z. Z nothing but what? Impedance of the circuit. R is nothing but what? Resistance of the circuit. If you want to define the power factor in terms of power, P is equal to, we have formula VI cos pi. Cos pi nothing but power factor. Cos pi is equal to P divided by VI. P nothing but active power or true power. VI nothing but operant power. So power factor is a ratio between active power to the operant power, or it is a ratio between resistance to the impedance of the circuit. Next, what is the relation between real power P, reactive power Q, and operant power S? So operant power S magnitude S is equal to root of real power square plus reactive power square. Next, two voltage vectors, they are in quadrature. What is the effective and they have the values, two voltage vectors values are 6 volts and 8 volts. The sum of the two vectors is how much? So it is going to be, as they are in the quadrature, the resultant vector will be 6 square plus 8 square. So this value is 10 volts. Next, question number 30. The units of operant power S. Operant power S nothing but it is VI. So V units are nothing but what? Volts. I units are nothing but what? Ampere. We represent with volt ampere, or we can also represent with kilovolts ampere, kVA or volt ampere. What is the units of real power? Watts or kilowatts. So what is the units of reactive power? Volt ampere reactive or kilovolt ampere reactive. Thank you. With this we have completed unit number 2, alternating quantities. In that first part, that is about the fundamental concepts of alternating quantity. In the next lecture we will discuss about whenever AC power supply is given to resistor, or AC through inductor, AC through capacitor, AC through RL, AC through RC, AC through RLC, and on resonance. On all these concepts we will discuss the previous year bit paper questions and solutions. Thank you.